Precalc students, this is Ms. Carranza, and today we're going to talk about Lesson 7.1, Part 2. Now in Part 1 of Lesson 7.1, I talked about how you can use the law of sines to solve oblique triangles, which are triangles where none of the angles are right angles. You can solve those by using the law of sines, and in three specific situations: when given angle, side, angle, 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 side, or the one most freshmen laugh at, ASS or SSA, side, side, angle. We have to be super, super careful when given side, side, angle. That's because even if they give you all that information, two sides and an angle, that doesn't mean that those sides and that angle form a triangle at all. So today we're going to talk about how can we tell if they give us two sides and an angle, whether a triangle is even possible. We have to be able to understand this concept before we even start solving triangles with SSA using the law of sines. Go ahead and write down the title of the lesson if you haven't done so already, and draw this oblique triangle. You can make up your own too if you want. As a quick reminder, you'll know it's SSA, side, side, angle, if they give you two sides and the angle that is not between them. So the angle might be over here in the bottom right corner, or it could be in the bottom left corner. So that's how you know that you've been given SSA. You've got two sides and the angle not between them. Because SSA triangles are a little bit more complicated than AAS or ASA, one hint that I hope you will use, it's technically a strategy, is when you're drawing your triangles, make sure that your missing side, so whatever side that they don't give you, right, in SSA they give you two sides, so there's a third one missing, make sure you make your missing side the base, okay? So whenever you are drawing the triangles out, because most of the time I will give you just the information written out, I will not give you a picture or a diagram. It's going to be your responsibility to remember this is only for SSA. Make sure the missing side is the base, okay? So always put that on the bottom, whichever one you're missing. Now, the way that you will know whether there's no triangle possible, one triangle possible, or two triangles possible has to do with the height of the triangle. A lot of math courses will call this the ambiguous case. So the ambiguous case only happens with SSA, side, side, angle. Ambiguous means unknown. So when I give you a triangle that's SSA, you don't know if it's going to form a triangle at all, one triangle or two triangles. So that's always going to be your first step before you even try to solve. I'm warning you, a lot of times people aren't careful. They start solving the triangle using the law of sines and they think they're done, but it can happen that there was no triangle possible or that there were two solutions, two triangles possible. Okay, go ahead and write this stuff down. Pause the video. When you're ready and you're done copying this, you can go ahead and unpause the video. Okay. Now, when given two sides and an angle, I'm always going to refer for these rules as the angle that you're given as theta. Okay. no triangle will exist if you take the opposite side of theta and find that it is less than the adjacent side of theta times the sine of theta. One triangle, oh, and really quick before I continue, I want you guys to know that this adjacent side of theta times the sine of theta is the height of the triangle. So this is actually the height of your triangle. Okay? Okay. One triangle will exist if the opposite side of theta, of the angle theta, is greater than or equal to the adjacent side. Oopsies. And last, you will have two triangles possible if the adjacent, or the height, so adjacent side from theta times the sine of theta is less than the opposite side of theta, and that is also smaller than the adjacent side. Now that sounds really nuts and complicated, right? It got complicated real quick, real fast. But I promise it'll get easier. And honestly, I spent hours trying to find the easiest way to explain this. Some people use quadratic formula. Some people use a lot of different ways to solve triangles, whether it's one triangle, no triangle, or two triangles, to decide whether they exist and how many exist. And I found that this is my favorite, simplest way. Remember that anytime you have the SSA, you draw the missing side as the base, and you do the adjacent side of theta times sine of theta, that's going to be its height. And I'll explain that as I do the problems. Like I was saying, I've looked at many videos, different textbooks. If you don't understand this lesson, you're more than welcome to do your own research and go to YouTube or Khan Academy and find a method that would work for you in how to understand whether no triangle exists, one triangle or two triangles exist when dealing with side-side angles. Okay, so we're going to do an example of each just so you get used to it. Okay, example 1. I'm going to go ahead and draw an oblique triangle. But before I label A, B, and C the way that I had been doing on the first day, A, B, C, for SSA I want to be a little bit more careful and use the hint that I provided. So I have little a, little b, but I'm missing little c. Little c is the side length that is across from big C. So since I want that to be the base, the missing side is the base, I'm going to go ahead and put that on the bottom. Remember, the missing side, you want to always try to have missing side as your base. Okay? So if that's little c, big C is across from it. Remember that angle is always across from its corresponding side. Now, I have angle A is 60. You can put that in on either side. You can put A on the left side or the right side. That doesn't matter. Because look at, I could put it like this. I can put the 4 here. That would make this B and the 5 here. You can still read the triangle as ABC if you go counterclockwise. Or, like I said, you can put the A here, B here, and it'll still be triangle ABC if you read it clockwise. In lesson 7.1, day 1, I told you that it doesn't matter how you go around naming it ABC. Okay. Sorry, as long as you go clockwise or counterclockwise. Now, I'm going to go ahead and just put A on the left corner, okay? All right. Let me finish filling out. So this would be 4, and little b would be 5. Okay, the height of this triangle is always going to be a vertical line drop down to the base, making 90 degrees. Okay? Now, this height length is always going to be the adjacent side times the sine of 60. So this length of the height is the adjacent side times 60, the given adjacent side. And that comes from SOHCAHTOA. So I've drawn, so if we just focus on this triangle and use the opposite over hypotenuse to find it, opposite over hypotenuse. So I'm going to do it really quick. You don't need to write this down, but the sine of 60 equals opposite over hypotenuse. Cross multiply, you see that it's 5 times sine of 60. So that's where this comes from. Adjacent side of theta times sine of theta. Okay, it comes from SOHCAHTOA. So I didn't make it up. No one made it up. It actually comes from SOHCAHTOA. Okay. Great. I'm going to take a look. So here's my given angle, 60 degrees. I'm going to look at the opposite side of theta. The opposite side of theta is 4. I'm also going to look and see what the height is. That's the adjacent side. Now notice there are 2 adjacent sides, 5 and C, but we don't know C, so we're going to use the given one. Adjacent side times the sine of the given angle. Remember, this is technically the height of the triangle. If the 4 is smaller than the height, that means no triangles exist. Okay, go ahead and put that into your calculator. 5 times the sine of 60. You should get 4.33. 4 is less than 4.33. So that means that this triangle is not possible. No triangle possible. If I had sticks, let's say, okay, that were 5 inches long, look at the given lengths, 5 inches long and 4 inches long, and I tried to form a triangle where C, let's say we found C, right, whatever length it was. If I were to try to do the 5 and the 4, C would actually be bigger, and I wouldn't be able to, so 5, 4, we'll call this A, C, and B. I wouldn't be able to draw a complete triangle because this is what would happen. So even if you would swivel it around, no matter whether you put it here, move it here, right, rotate it, you'll never be able to connect it. So the length of 4 is just not long enough to create a triangle. That's what this triangle actually would look like based on those measurements, okay? But there was no way for us to know that unless we did the math. So the actual picture for that information is something more like this, where there's just no triangle possible. That line segment of CB is just too short. Okay. You'll know one triangle exists if the opposite side of theta is greater than or equal to the adjacent side of theta. So this has nothing to do with the height. This is One triangle exists as long as you're just looking at the sides and this relationship is true. So notice that I'm not given little c in this one again. So I'm going to go ahead and make that the base. Remember, whatever side is missing, you want to make the base. Now, it doesn't matter whether you put the A and the B, where you put them. You decide, okay? I always read I'm a right-handed person, so I always go from left to right. So I'm going to go ahead and put the 50 there. Okay. So I'm going to drop down the height. It's just a tendency that I have when I do these, but again, when you know it's one triangle, you don't even have to look at the height. You're just going to automatically notice that the opposite side, which is little a, is bigger than the adjacent side. Now again, there are two sides that are adjacent to the 50, but you're always looking at your known side. So in all of these rules that I wrote for you, when I refer to adjacent side, I'm talking about the given side, okay, from SSA. Okay, so take a look. Opposite of 50 is 3. 3 is definitely bigger, not necessarily equal to, but greater than or equal to 2. So then automatically I know that this has one triangle possible. So this is going to have one solution when I solve it. We'll solve them on a different day, but today we're just practicing whether or not the triangle is even doable. Because if I give you an example like, or if I give you a problem like example 1 on a test, and you use law of sines and you solve it, you spend probably 5 or 6 minutes doing something you didn't have to because there was no triangle possible. Okay? Okay. Let's draw the next triangle. Remember, you can pause the video at any time, guys. Pause the video at any time, rewind it, replay it, send me a message if you need help. Okay. When I have SSA, I'm going to be super careful when I draw it, and I'm going to use my strategy where I keep the base as the missing side. So I have little b and little c. I'm missing little a. So I'm going to make little a the base. Okay. I'm going to draw in my height. Okay, now I'm going to I could put B or C anywhere I want. Like I said, I'm right-handed, so I always go from left to right. Okay, so B is 20 degrees. Little c is 6. That's across from big C. And little b is 4. Okay, now I am going to see whether the height, which is adjacent side times sine of theta, remember it comes from SOHCAHTOA, so I'm going to do it for you, but you don't need to write this down. Let's say this is x. Opposite over hypotenuse. Sine of 20 equals opposite over hypotenuse. If I cross multiply, the height is 6 times sine of 20. So that's adjacent side times sine of theta. Okay, so that's the height, like I said. 6 times sine of 20, adjacent side times sine of theta. Okay? Multiplication is the little degree sign. Okay, so we're going to need the height, so go ahead and put that in your calculator. 6 times sine of 20. Okay, I've got 2.05-ish. Okay? Right, so that's the height, 2.05, and I'm going to see if it's between the opposite side of theta, which is 4, and the adjacent side of theta. Adjacent side of theta. So I'm going to go ahead and put that over here. I don't know why I didn't write it before. Okay, adjacent side of theta is 6. 2, this is a true statement, 2 is less than 4, which is less than 6. So that would mean that 2 triangles are possible. In this situation, we would have to draw the 2 triangles. Now, if you're like, okay, well, where are the 2 triangles? best way I can show you is to, I just copied and pasted that triangle, and you can do the same. So take a look at that length of 4, okay? The other triangle that is formed is by taking this length of 4 and rotating it. So imagine it as if it was like a stick, okay? So a stick on a paper, or a matchstick or a pen, right, on a paper, and you rotate from point A, rotate it in a circle. I know it's not the best. And put it over here, okay? So if I were to take that 4, that length of 4, so I just copy the length of 4, okay? Let me show you. Okay, so this 4 I got from here, okay? So if I were to take this 4, so just imagine if it was just like a little matchstick or a pen on paper, right? So if I were to take this length of 4 and rotate it, so think of it swinging it around, put it over here. It's going to be tight, but you can see that it forms another triangle. Where the 20 is, I know it's like teeny tiny, but that's where the other triangle is. So the 20 is still here. B is still here. We're keeping the 6 as originally given and the 4, but then angle C in the first triangle was acute, and angle C in the second possible. Okay, I don't know why my program just shut down at that second, but you can see that this little triangle is still possible using the lengths of 6 and 4. The 20 degrees is still there, so I'm still using the given SSA, but it creates, instead of an acute triangle or acute angle for C, you have an obtuse angle for C. And we're going to talk about that more on 7.1 Notes Day 3. But that's, hopefully that helps you understand how you can go from one triangle to 2 triangles possible. Okay, now on your homework, you are going to be given information about a triangle, and your job is to find out whether it forms 1 triangle, 2 triangles, or whether a triangle is not even possible. Okay, so your homework's going to look something like this, okay? State the number of possible triangles that can be formed using the given measurements. All right, so take a look at number 1, for example. We are missing side A. So I'm going to make that my base. You can put B and C wherever you want. Label things accordingly. I like to always label my height. You don't have to do this if you don't want to. And then what else do we know? Little b is 12 and little c is 15 inches. Okay. All right. Now, what I'm going to do is I'm going to go through the 3 possibilities. I'm going to ask myself, is this no triangle? Well, to do that, I need to check, is the opposite side of theta less than the height of the triangle, which is adjacent times the sine of your given angle. Well, let's see. Your given angle is 36. Opposite side is 15. And I'm going to see if that is less than the height. So the height is the adjacent side of your angle. Now look, here's your angle. There's 2 adjacent sides. I'm going to use the one that's given. So I'm going to use the 12. 12 times the sine of my angle. 12 times the sine of 36 is 7.05-ish. That is not a true statement. 15 is not less than 7.05. So that means that it is possible. It would not have been possible if 15 had been less than 7.05, but that's not true. So now I'm going to ask myself, is one triangle possible? And the rule for that is to check if the opposite side of theta is greater than or equal to the adjacent side of theta. Okay, well here's my theta, 36 degrees. I'm going to look at the opposite side, that's 15, and I'm going to see if it is greater than or equal to the adjacent side. So again, when you're looking at an angle, there's two adjacent sides, but you're going to use the given one. Is this a true statement? 15 is greater than or equal to 12. Yes, it is true. This was not true. So that's how I knew it couldn't be this situation. But if you get a true statement here, then that means that that's your answer. So this has one triangle possible. Now let's say this hadn't worked, you'd have to go to your last option, two triangles possible. In this case, you need to check the height, see if it's smaller than the opposite side, and see if that is smaller than the adjacent side. So my height, if you remember, was adjacent times sine of theta. This guy was adjacent times sine of theta, which I got, let's say height. Height was 7.05. Okay, I already found the height, 7.05. I'm going to see if that's less than the opposite side. The opposite side was 15. That's true. But then it also had that 15 has to be less than the adjacent side. And the adjacent side was 12. So even though this is true, this part is not true. So then that means this isn't the situation. So you guys see that? That's what you're going to have to do on your homework. You're going to look at the given information, draw your triangle, and go through each scenario. Could it be no triangle? Use the formula, or, you know, when I say formula, I'm talking about this, these explanations. Opposite side of theta is less than the height. That's for no triangle. One triangle is just comparing the opposite sides, seeing if it's greater than or equal to adjacent side. And then two triangles is if the height is less than the opposite side of theta, which is then less than the adjacent side of theta. All right, guys. Let me know if you have any questions. And as always, I'll be happy to help. Have a good day. Bye.